Hello, today we'll be doing number 55, which is find the antiderivative of ln x squared plus 1 dx, and our first step has to be using integration by parts. So just as a brief review, the integration by parts formula is the integral of uv prime equals uv minus integral of v u prime. So we can set our u equal to ln x squared plus 1, our v prime equal to 1 because 1 is easy to integrate, and we have uv, or ln x squared plus 1 times antiderivative of 1, which is x, so x ln x squared plus 1 minus the antiderivative of v, so x u prime. And derivatives was a while ago, but you should remember that for this part we have to use the chain rule. So that's going to be 2x over x squared plus 1. 2x squared over x squared plus 1. Simplified. And now we can use a trig substitution. You see that x squared plus 1 in the bottom? That's in the form x squared plus a squared. So we can use x equals tan theta dx equals secant squared theta d theta. And just plug stuff in. Let's factor out the 2. 2 times the integral of tan squared theta over tan squared theta plus 1. So by that, if you divide sine squared theta plus cosine squared theta equals 1 by cosine theta, you get tan squared theta plus 1 equals secant squared theta. So you have tan squared theta plus 1 in the denominator, and that just becomes secant squared theta. And don't forget about the dx, which we now replace with secant squared theta d theta. This is where we are right now. So we can just eliminate the secant squared thetas, and that's just 2 times the derivative of tan squared theta. So you could do this in multiple ways, including that power reduction formula, but I think that it's easiest to just use the identity we previously used and switch tan squared theta back into secant squared theta minus 1. The reason we're doing this is because now we can find the antiderivative of secant squared theta, which is just tan theta. And of course, the antiderivative of 1 is x, or theta in this case. So we now have 2 tan theta minus 2 theta distributing. And right, we plug that back into the top. We have to remember what we're solving for, and we get x ln x squared plus 1 minus 2 tan theta minus 2 theta. That's not going to fly. We need it in terms of x. So if we set x equal to tan theta, it follows that theta equals arctan x. So that's just going to be 2 tan arctan x. The tangent of the arctangent of something is just that something. So that's going to be minus 2x minus that 2 theta is just going to be, first of all, it's going to be distributed, so that's going to be plus 2 theta. And second of all, that's going to be plus 2 tan inverse of x. Yes, that is our solution. Okay, so hope this helps.